Thank you for joining me. Welcome to TJ's Maths Clinic. Still on differential calculus, we're looking at differentiation from first principle. This is one of the methods of differentiation. So let's look at how we can handle this. Suppose we have our Cartesian plane where we have x-axis and y-axis. Suppose we are trying to find the slope of this straight line, which is giving us this. We are trying to, let's say, the coordinate here, let it be A, which is x1, comma y1. The coordinate here, let it be B coordinate, that is x2, comma y1. Of course, let the coordinate here be C, which is x2 now, comma y2. If we are to find the slope of this line A to C, is nothing but m, which is change along the vertical axis divided by the change along the x-axis. This is the same thing as y2 minus y1 divided by x2 minus x1. Very important. We know that x is a function of y is a function of x. It means y is equals to f of x. And since y is a function of x, meaning whatever the value of x will determine the value of y. So x is a function of y is a function of x rather. Y is a function of x. Then we can deduce that y1 will be equals to f of x1, then y2 will be equals to f of x2. Very important. And again, we know that changing x is nothing but x2 minus x1. So we can find x2 here. Let's bring this x1 to the other side. X2 now will be equals to x1 plus changing x. Very important. Okay. So it means we can substitute. We have our slope m now as in place of this y2 is the same thing as f of x2 minus y1 is the same thing as f of x1 divided by x2 minus x1 here. X2 minus x1 is nothing but delta x. So we have delta x. Very important. Again, this our m is nothing but delta y divided by delta x. So we can say change in y with respect to x now will be equals to f of, in place of this x2, if we check here, x2 is nothing but x1 plus change in x. So we can say in place of this x2, replace x1 plus change in x minus f of x1 divided by delta x. Very important. If we want to get more accurate result, if we decide to move this coordinate of C closer to this A, the change along this x-axis will tend to be 0 so that we can get more accurate result. So if we shift this coordinate to this first coordinate here, the change along this x-axis will tend to be 0. So we can deduce that change in y with respect to change in x now will be delta y divided by delta x, as the limit of delta x tends to 0 now, will be equals to f of x1 plus delta x minus f of x1 divided by delta x. This is said to be the derivative of a function from first principles. So this is the general formula we are going to use. Very important. So let's look at the example 1 quickly. Suppose we are asked to find the derivatives, e.g. now, 1, we are asked to find, if we have y equals to x squared, and we are asked to find the derivative of this function. We know that our f of x now will be equals to x squared, because this y is the same as f of x, since y is a function of x. Very important. we know that changing this y now will be equals to, in place of this x1 plus changing x, we replace it here. That will be x plus delta x, but we have square here. That's all square now, minus f of x1, which is the same as f of x, is x squared. That will be x squared. Very important. Let's expand this. Changing y now will be equals to, if we expand this, we have x squared plus 2 delta x plus delta x all square minus x squared. Let me do the expansion here so that we can get that. The expansion is, we have x plus delta x all multiplied by x plus delta x. X times x, that's x squared. X times plus delta x, that will be x delta x, plus we have x delta x plus delta x all squared. This will be x squared plus x delta x plus x delta x will be 2x delta x plus delta x all squared. This is how we come about, we have 2x here, sorry. This is how we come about this expansion. 2x delta x, 2x delta x plus delta x all square minus x square. You can see clearly that we can remove this x square, because x square minus x square will be 0. We are left with change in y with respect to, change in y now will be equals to 2x delta x plus delta x all square. The next thing for us to do here, let's divide through by delta x, since we are looking for changing y with respect to changing x. So let's divide through by delta x now. Each term now, we divide by delta x, divide this by delta x. Very important. Okay, so if we divide through by delta x, we'll have changing y now with respect to x will be equals to, this will do our, we were left with 2x plus, we have 2 delta x here. So if we, delta x into delta x will be 1, delta x will remove one of the delta x, will be left with delta x like this. So the limit now, or changing y with respect to changing x, will now be delta y divided by delta x, as the limit of delta x tends to 0 now, will be equals to, anywhere we see delta x, we substitute 0. So it will be 2x plus 0. So finally, changing y now with respect to changing x will now be dy by dx now, will now be 2x. Very important. So the solution to this is nothing but 2x. If we use general method of differentiation, we can still get this 2x. Why? Because we have y equal x squared. Changing y with respect to changing x will be equals to, we drop down this 2, that will be 2x. Reduce the power by 1, that will be, of course, 1. That will be still 2x. This is said to be the solution to this question. In my next video, we'll look at more example from this first principle. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ Smart Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.